Good afternoon, everyone, and thank you for joining us. My name is Abby Dorian, and I'm the Head of Energy at BSI. Today, I'm very pleased to be joined by key industry experts to launch the Fourth Amendment of BS 7671, also known as the IET Wiring Regulations, which is the UK's national standard for the design, erection, and verification of electrical installations. Since 1992, the IET and BSI have worked together to develop and produce editions of the wiring regulations under the Joint Technical Committee JPEL 64. This standard brings together both European harmonised standards and international standards to provide a single authoritative framework for safe and compliant electrical work in the UK. Today, I'm also very proud to announce that this year marks a milestone for BSI. It marks 125 years of standards making that have protected people, enabled commerce, and driven technical excellence across the UK and globally. In 1901, BSI published our first standard. It was a specification for steel sections, but since then we have published over 100,000 standards from everything from pharmaceuticals to aerospace, cybersecurity to food safety. And running across all of these standards is a single principle: that voluntary standards developed by experts, which are rigorously reviewed, exist to make things safer and better. Amendment 4 of BS 7671 is the latest chapter in that 125-year story. And the wiring regulations is the product of expert consensus from engineers, installers, regulators, and safety specialists working together to ensure that the standard remains the living, authoritative backbone of safe electrical practice in the UK. Decarbonising the UK requires more than just installing hardware. I think we all know that, but it requires a unified language on safety. And as our energy system shifts from a passive model to a dynamic and decentralised one, BS 7671 also evolves to manage that complexity. Amendment 4 is the latest iteration of that language, ensuring that as we move towards 2030, our standards for protection, isolation, and integration are as advanced as the smart technologies that they support. Working alongside the IET, BSI is releasing this update at a critical inflection point for the UK. As we push towards 2030, our focus is developing the standards needed to support a clean energy system that is as resilient as it is innovative. And BS 7671 is the foundation for that. It provides the central technical certainty we need to roll out the large-scale electrification required the net zero economy safely. So let's get to today's session. We recognise that with any new amendment comes a period of adjustment, and the sheer volume of content can sometimes obscure the practical application, which is why our focus today is on ensuring that you understand the new changes in Amendment 4. And our goal is to ensure that you're not only aware of these changes, but that you're well placed to understand their applicability to your specific projects, both now and as technology evolves. We know that misinterpreting, misunderstanding, or overlooking updates in BS 7671 can not only be an administrative headache, but can actually create genuine gaps in the safety chain. And so the purpose of today is to try and minimise or eradicate those gaps wherever possible. By the end of today's session, we hope that you'll have practical insight into the most critical updates, but that also you'll have the real world context as to why those changes have been made. And most importantly, you actually have direct access to some of the key technical experts that were the bread and butter of getting 7671 to where it is today. So speaking of, to guide us through the Amendment 4, we have an incredible panel. First, I'm joined by Mark Coles. He's from the IET, but he's also the committee manager of JPEL 64, the Essential Technical Committee developing BS 7671. There is no one better placed to walk us through some of the key updates and give us context as to why those updates have been made. After that, we'll dive into one of the most anticipated new elements of BS 7671, the new chapter on batteries. And to do that, we're joined by Luke Osborne from Electrical Safety First. And then we'll be wrapped up with a user experience on 7671 from Kirsty Johnson from Surge Protection Devices, who will share how these standards actually translate to the front line of installation and protection. After we hear from each of our experts, I'll give each of them the limelight for about 10 to 15 minutes. We'll turn to an open Q&A. So please do make full use of the Q&A function, we're welcoming in your questions and we'll work through them with as much time as we have. And so I know we've got a lot of ground to cover and the clock is definitely ticking. So I would like to get straight into the bread and butter of today's conversation, and it is my absolute pleasure to hand over to our first speaker. Please welcome the Committee Manager of JPEL 64, Mark Coles. Mark, the floor is yours.
Thank you, Abby. What an introduction. What I'd like to do is go over why there's a Fourth Amendment, why now, and what's driven this change. Conventionally, with British standards, we see that 2 amendments happen. Of course, we've got 4 now, but why 4? The reason was, you'll probably recall, back in 2020, we had a quick amendment which was necessary for EV charging. That came out of the woodwork, and the committee had to act pretty sharpish. We then go to BSI and say, hey, we're planning 2 amendments. Can we have another one? And that's what happens. In 2024, the same thing happened with bidirectional, unidirectional devices. It was deemed to be a safety issue. The committee had to act sharply with that. So we requested permission, and that led to this being the 4th Amendment, because we were already working on the 3rd Amendment, which became the 4th Amendment, and it gets pretty confusing. The next question, I suppose, would be, could there be a 5th Amendment? Well, there's no reason why not. If something comes out of the woodwork, we need to act sharpish on that, then there could be a 5th Amendment, but let's hope not. Let's hope we've got all bases covered at this point. Now, if you've got a copy of the Orange Book with you, you'll see in page 18 the preface, and the preface shows all the IEC and CENELEC documents, CENELEC HDs, harmonized documents. But you'll see all these standards which are brought into BS 7671, and you'll see to the right-hand side of each of these standards, as they're listed, there'll be a date. Now then, these standards internationally, they leapfrog each other. They're not all amended at the same time. Committees work on particular documents. Some are maintained more often than others. So what we find is that these standards come through in a drip kind of fashion, and we have to adopt them because, being part of CENELEC, we are obliged to incorporate the requirements of harmonized documents within our national standards within the UK. So BS 7671 is no different. So every change that occurs within CENELEC, within this 60364 series, we have to implement. Now, conventionally, it's kind of 3 years, but we update BS 7671 thereabouts every 4 years. And the reason is because changes occur, technology is advancing, we need to keep on top of what's going on. So that's the reason for the change now. We hear many voices saying, oh, not another change, another amendment, we have to buy something else. And I do feel the pain, we do feel the pain on our side. But what's the alternative? We could sit there for 10 years. We could make a decision and say, right, that's it, let's keep the standard steady for 10 years. We'll do the courses now, we'll buy the books and things we need, we're up to date, and we sit there for 10 years. But in 10 years' time, the rest of the world keeps moving. And then we find that the UK is well behind everybody else. And the speed and the investment necessary to bring everybody up to speed at that point, the rest of the world, will be absolutely enormous. So I don't think there's any 2 ways about it, that the world is advancing at such a fast rate, we have to keep up with it, and the standard will continue to be amended. It's natural. So that's what I wanted to cover there. Now then, delving into the content of BS 7671, I want to touch on battery storage because that's what Luke's going to cover on his session. But I want to cover briefly other changes, and just to pinpoint and point you towards other bits and pieces that you may find interesting that have slipped through. Of course, we saw the press release that came out for BS 7671, and there were 4 particular areas in there. That there was battery storage, stationary secondary batteries, medical locations, section 710, 716, which is power over Ethernet, and then 545, which is earthing and bonding in ICT situations. Of course, beyond there were many other changes too. Now, as I said, Luke's covering battery storage, but I'll just cover some changes that have come in through those main sections and then look at some other snippets to point you towards. So within section 710, medical locations, you'll see there is a regulation under 710.419. Now, those with a keen eye will know that section 419 are situations where you can't achieve a disconnection time. 41 is all about protection of safety, electric shock, and we have disconnection times in there. But 419 acknowledges that in certain situations, you might have an inverter, variable speed drive, that can't switch off in a particular time. It might be down to the source impedance or the way the electronics work. So the requirement is that the output of these sources reduce to 50 volts AC or below within the disconnection time. So where I'm going with this is, within 710.419, the introduction of the UL, and UL is the constant touch voltage that is acceptable in medical locations, and this is lowered to 25 volts. Conventionally within BS 7671, the general rules, you'll see it's 50 volts. But in this particular area, it's reduced to 25 volts. And this is a voltage that they're happy for it to sit there continuously because you've got bonding in place. Again, that's 419, where you can't achieve a disconnection time, and a voltage will sit there constantly. So UL has been introduced there. Also, you'll see within section 710, there's a requirement on 710.514, which is for diagrams and documentation. There's a requirement there to provide a schematic diagram for the supplementary equipotential bonding required in these areas. Now, we've probably seen in, if we've ever been fortunate to be inside hospitals in certain areas, we see the bonding connections into bus bars, and often behind glass screens, and they're labelled up. The requirement now is to provide a schematic diagram showing where they start and they finish. Then you'll also see in Annex, I think it's B710, there's a new form which allows you to once you've tested these connections and these conductors, you then put the information into the table. Now, what the committee found over time was that when a contractor goes into these particular areas to carry out the testing of the bonding, it could take them 2 hours, for example. And the concept here is that with a schematic diagram and the form to work to, you can get through this work within 15 minutes. So it isn't all bad news that's been introduced with amendments. This is certainly good news for the workers in there. So that's what I'd like to cover on medical locations. What I'd like to touch on in 722, this is supplies for electric vehicle charging. There's the inclusion of an RDC PD. So this is an RCD that operates in DC, that's the RDC, and the PD is protected device. So we see that in certain circumstances and installations, we need, type A, B, F RCDs. There's also another option here of going down the RDC PD route. So do look at that one. Beyond that, I'd like to highlight what's happened with EICRs. This is the form in Appendix 6. So you'll also see in there, in the EICR form, that there's been a very definite separation of codes 1 and 2, C1, C2, and then C3 and FI. So when inspecting an electrical installation, if you pick up a C1 or C2, so C1 is where you have bare conductors, instant danger. C2 is where you've got a danger once something has happened. So there might be no connection to earth, for example. It's sitting there happily and working, but until something happens, you're not at risk. So where you get C1 or C2 that's being picked up, it's an immediate unsatisfactory to record for that installation. Now then, where there's a C3 is where the installation could still be satisfactory. There might be some non-compliant, maybe not some non-compliances, but non-compliances with the standard, which don't really mean anything, not an issue of safety. So where C3 is recorded, the installation can still be satisfactory. Now then, FI is being brought out of it all, and it sits with C3 because an FI shouldn't result in an immediate unsatisfactory. An FI means further inspection necessary. So it means that you've found something on site, and what you're recording is to your client. Further investigation is necessary because there could be something going on there. We don't know what the end of this cable is. It goes off somewhere into the building. We can't find it. In any event, you don't know what's in the end of there, so you can't, hand on heart, provide an unsatisfactory result. And that's been the thinking behind it. So I'd like to end there, Abby. There's many aspects of it all I could talk about, but I'll probably get into too much detail.
No,
but we could probably pick these up within the question and answer session.
Absolutely, and thank you so much. I think it's always helpful as well to hear about the rationale for the use of amendments, just to make sure that we're keeping pace with the scale of innovation and change, and also the risk profile for this sector, but also what actually the users can expect in this new amendment. So that's really, really helpful. With that, I might pass over to Luke Osborne to walk us through the new and highly anticipated chapter on batteries. Luke,
thank you very much. That's going to be a tough one to follow. Mark did that free reign with no notes and no auto cue. So yeah, that was very impressive. So yeah, apologies, you've got me now. So I'm going to be covering, as Mark mentioned, the new chapter on battery storage, stationary battery storage systems. So we're going to be looking at, well, first of all, what were the drivers for this change coming through? There's been a number of things changing around us. We have the move to a greater amount of electrification. We have increased adoption of flexible energy systems and dynamic pricing, time of use tariffs, and other ways to encourage flexibility. and the ever-growing adoption of solar PV among many users, whether it's businesses, whether it's domestic use, as well as we've seen in the news, the need for energy security. And all of this is driving a massive, rapid growth and adoption of battery storage systems. And so that's why it's really important to have a new specific chapter within BS 7671. Mainly because batteries can both be an energy source and a load at the same time. And within that, voltage is always going to be present. So there's additional things for the installer and the users to be aware of. You've got high electric shock risks. You've got high elements of DC fault currents available, and also the increased thermal effects. And all these things can lead to the options of fire, arcing, and explosion. And we've got increasing use of great technologies here, but we want to make sure that it doesn't result in things like this. Obviously, you'll notice that's an AI generated image, so please don't pick fault on the various wiring systems on there, because obviously that was deemed to generate a problem like that. But this new chapter should draw attention to things that will provide safer installations going forward. And additionally, is to help formalise requirements. You've already got options to access the IT's Code of Practice for electrical energy storage systems. We have PAS 63100, which has been around for a while. And we've also got the MCS standard for battery storage systems. But now having these explicitly, having some of this information explicitly within BS 7671 just makes it clearer and easier for installers to understand what's required and what things should be considered. So what's in scope? Well, it's quite a simple statement within the header of the chapter, and that just says stationary secondary battery installations where the designed purpose is for storage and supply of electrical installations. Now that's rather vast, so it's probably easier to look at what's not in scope. So any batteries that are contained within products that are covered by product safety standards are not in scope, and nor are alarm systems, fire detector and fire alarm systems, pluggable UPS systems, emergency lighting, machinery, and any EV related systems, which obviously have their own section in section 722, which Mark referred to and also alluded to in chapter 82 as well. And it's really important to consider a number of factors when you're deciding with your client what sort of battery is going to need to be installed. So what's the connection going to be? Is this going to be AC coupled, or is it going to be connected via DC? Is it going to be going into a hybrid inverter coupled with solar PV, for example? What's the battery voltage? And this is really important where you've got separate PCE systems or stackable batteries as well that can be kind of linked in. And also any generation profiles that are within those buildings, particularly at the moment with solar PV, but this could extend to any other sort of generation devices as we go forward. What's the demand going to be of the customer? What are they expecting the battery to be able to deliver? And that links into the battery charge and discharge profile. So how quick can the battery charge? How quick can it deliver that stored energy? And also the load profiles and the cyclic operation capability of the batteries themselves. We'll explore a little bit of this in the next slide. And some of these aspects are really key to draw out with your customers. For example, you may have a 10 kilowatt hour battery, so fantastic amount of capacity, but the use of that battery for that client is going to differ, and also the rate of delivery of that battery is going to really dictate whether your client is happy with the demand. For example, if you've got a 10 kilowatt battery, looking at the curves here, if it has the capability to deliver 10 kilowatts per hour, that would be deemed as having a C-rate capacity of 1. So it could deliver 10 kilowatts of energy consistently for 1 hour. if it's rated at being able to deliver 20 kilowatts at a moment in time, that's only going to last for half an hour. It's quite simple, it's quite straightforward, but these are the things that need considering. And so it's important for your clients to understand what they're intending this to provide. So if, for example, they wanted to make sure they weren't importing power and they were solely using the consumptive, the provided power of the battery for electric showers, electric heaters, washing machines, tumble dryers, that's really going to drain that that battery quickly, and that'll align more with the green curve that you can see on your graph there. But for other devices, most of your electronic devices, your TVs, your fridges, your LED lighting, and your laptops, they're really low energy loads, and so they'll really extend the amount of time that battery is going to be able to supply the property if it was in an off-grid scenario. So it's really important to have those conversations with the clients. Now, I'm not going to be able to cover all the different regulations that are in the book. Obviously, you've hopefully now got your bright orange copy in front of you. But I'll pick out a couple of key ones that are probably worth referencing. There's some important ones which relate to the maintenance and replacement of battery storage systems, particularly 570.6.1.1.2, highlighting that the voltage at the terminals of cells and monoblock batteries should always be assumed to be present, and that appropriate provisions for safe maintenance should always be provided. This is exemplified in 570.6.5, stating that every power circuit connected to a stationary secondary battery shall be provided with an appropriate means of isolation. And it's quite likely that this is going to be required at both ends of that power circuit, just to help facilitate the maintenance, repair, and replacement of these devices. And also, further emphasised in 570.6.5.201, to allow the replacement of PCE not incorporated into the battery assembly, a means of isolation shall be provided for all power ports. And this could be where you're using a hybrid inverter, which could be located in a loft or a separate location to where the battery storage units themselves are going to be. So to make sure that every step of the way there is that sufficient ability for maintenance and replacement of the devices. 570.621.201 goes on to talk about basic protection. All battery connections need to have basic protection by insulation or enclosures where there's a difference in voltage exceeding 120 volts between the conductive parts that could be touched simultaneously. I think that goes without saying. And then 570.6.1.2.2 refers to the protective earthing. And this is particularly to prevent any circulating currents within TNS or TT systems to make sure that they are earthed at a single point. And this also needs to take into account the correct operation of protective devices to make sure that they operate in a suitable time. So all these things are really key to designing your systems. Akin to some of the other requirements in BS 671, which we've seen relating to solar PV, for example, automatic disconnection of the supply provided by an RCD needs to be a type B unless there is at least simple separation between the AC side and the DC side, or at least simple separation between the PCE and the RCD through the separate windings of a transformer, or unless stated by the manufacturer. So very similar to what we see in 712, but equally applicable as well. And it's important to consider the thermal effects. Obviously, you've got quite a lot of heat can be generated in charging and discharging battery storage systems. So it's important that the location and the enclosure of these batteries are adequately ventilated, and that the manufacturer's instructions, as always, is taken into account. And this will be to prevent damage to the batteries, which can be really affected by increased heat or extreme cold, and to help maintain the battery temperatures within those specified by the battery manufacturer. And again, this is emphasised in 570.6.7.202, stating that the batteries need to be located and adequately ventilated. Taking into account the manufacturer's instructions, but making sure that the ventilation does not create a hazard, and that there could be the requirement to ventilate to an outdoor space. So all these things can help in influencing where your battery storage system is going to be located. There's some particular points on protection against fault current for the DC side, so 570.6.4. When determining the prospective fault current, you need to take into account not just the contribution provided by the battery, but also anything that the PCE is going to be likely to feed into this as well. And that's particularly important when coordinating the particular type of protective device, thermal effects for ABS, and ensuring that the lowest usable voltage provided by that battery storage system is taken into account. Now, I mentioned PAS 63100 earlier on when we were looking at the existing documents that are out there. And there's a particular regulation now, 570.6.7.203, which makes direct reference to this. So stationary secondary batteries in dwellings need to be installed in a suitable location, taking into account not only manufacturer's instructions, but also the recommendations of PAS 63100. Now, this particular part is only related to dwellings. There is a second part to this which says that in other premises, the location of storage batteries and fire protection shall need to take into account the fire strategies of those buildings. But for the next couple of slides, I just wanted to particularly look at dwellings. So looking at PAS 63100, it's quite specific in where it says you should try to locate a battery storage system, or try not to locate a battery storage system. Ideally outside is the recommendation, so not within a property, but not within 1 meter of a door, nor a window, nor any ventilation. So this, when you look at this pictorial here, it starts to really limit the applicability of being able to place these outside a building. These are recommendations, but they need to be taken into account. And as an installer, you need to demonstrate that these things have been considered. But where it hasn't been able to be placed outside, there is the option to be placed within a building. But there's also some other key concerns to be taken into account. So the battery storage system shouldn't be placed within a bedroom or anywhere where people are likely to be sleeping. Equally, they shouldn't be placed in cupboards or any other storage units within a bedroom or anywhere someone's going to be sleeping. So that's quite clear. It can't just be hidden in a cupboard and still installed in a bedroom. But there are other considerations as well. It can't be in anywhere that's considered a route of escape from the building, under stairs and other similar places that are going to really impact people being able to escape from a building. And also, I mentioned earlier on where you've got separate PCE from the batteries. If the PCE is going to be installed somewhere that isn't located very frequently, this could be loft spaces, store cupboards and other infrequently visited locations, it's imperative that a smoke alarm, a smoke detector, multi-sensor fire detector and fire alarm systems are also installed in that location and interlinked with fire detection systems. And this is really important to give occupants that early warning to be able to exit the building should something untoward happen. And that's it from me.
Fantastic. Thank you so much. I think we're just trying to get the camera back. Thank you so much, Luke. That was really insightful and very helpful to step through the regulations in that level of detail. It's great to see that this new chapter for batteries is so well contextualised in the existing frameworks and guidance, and how interconnected all of the different PASs and existing guidance from MCS and IET are also considered in that chapter. So thank you very much for that. And to wrap us up in terms of our expert insights, I'm passing over to Kirsty Johnson to give us a little bit of an insight into the actual user experience for BS 7671. Thank you so much, Kirsty.
Thank you, Abby. So today I'm doing something slightly less technical than the gentleman that I've just been presenting, but hopefully you'll still find it interesting. So it's looking really at why BS 7671 is the way it is and why it's so interesting. It's probably one of the most interesting standards we have that are in within with BSI because of how it's run. Abby mentioned previously that it's run as a joint committee between BSI and IET, which is absolutely fantastic. You bring together so many industry experts, like people like Mark from the IET. We've got Luke here from Electrical Safety First. You have industry experts like me that are on the committee. So we draw on different experts all the way around the industry to make sure that the BS 7671, when it's released, is the final thing that is going to be helpful to you guys when you're actually working with it. So obviously BS 7671 is central to everything we do in the electrical industry. It's it's our national benchmark for our electrical safety. Although it isn't law, which a lot of people still don't realise, BS 7671 is not law. It's how to show that you are working to the electricity at work regulations. So it is a very, very important document. It not only protects the people in our lives day to day, everybody uses the electrical industry, whether they think they do or not. Even people that turn their light switches on at home are all reliant on BS 7671 in the electrical industry. So it protects the people, it protects our property, and it protects our electrical systems. It provides really key consistency across our electrical industry. It means you should be able to, in theory, walk into any electrical installation in the UK and know it all works to the same system. That also helps us then produce verification for all of our electrical competence within the installation industry, with our electrical industry. Everybody works to the same book, whether you're working as an apprentice and you're still learning your trade, or you're a practice seasonal consultant that's working on an electrical schematic. Everyone is working to the same book. It also means then when inspectors and insurance people, anything like that, are looking at things when they go wrong, they're always looking from the same place, and it's a recognised then standard. If I could just have my next slide, Doris. There we go. So Mark did cover why we have an Amendment 4, so I'm not going to go too much into that. But what it is important to know is that the UK is the only one that has a book that is bringing together all these different standards. So all of our different parts are different books in the European industry. So rather than us have all these different books, we bring it together into one standard, which means it does need updating. But the reason most of us went into engineering, and me specifically, I went into the electrical industry, is because of how fast it moves. I'm absolutely a giant nerd. I love new technology, and we are in the industry that probably moves the fastest. For us to be able to stay on top of that and make sure our installations are as safe as possible, it does mean we need to update our standards to reflect that. One of the big things at the moment in the industry, as Abby mentioned before, is moving towards our clean energy goals and electrification in the industry. Obviously, we've just been discussing battery storage with Luke. EV chargers are a big part of that, and moving towards them lower carbon technologies. As we're increasing in the industry how much of that we're installing, we need to make sure our standards stay ahead of that. I mean, I know for a long time, and many of you probably are already designing and installing battery storage systems, but now this is a new chapter that we've just released to be able to be on top of that. So us having these standards makes sure we bring everything together into one central point that's usable for our industry. So BS 7671 isn't something that just sits on a shelf where it definitely shouldn't be. Can I just have my next slide, Doris? Thank you very much. It's embedded in everything we do, whether you think about it or not. I mean, I know for many of you people that are working on site on a day-to-day basis, you probably think through things through like selecting your cable and making sure which protective devices you're using. You probably do it without considering BS 7671. But what underpins all of our electrical decision making is BS 7671. We apply these regs on a daily basis, whether we think about it or not. And it gives us our basis for our certification and documentation, ensuring our EICs and our EICRs, as we were discussing the coding changes, it makes sure that our documentation is all up to date and up to standard. It makes sure the industry is confident in the work that we're doing. Everyone can be confident in the work that we're doing because it's the latest standard and we are working to the best of our ability by using it. The everyday application of BS 7671 is what makes it such a powerful document. As I said, it is used by everybody that uses a light switch on a day-to-day basis, whether they know it or not. So us ensuring that BS 7671 is the best document it can be is at the key of everything we do when we're working on JPEL. The last slide is something a little bit more personal. So it was more of where I wanted to see BS 7671 go in the future. So I'll be very clear that these are my views and not those of the committee or BSI. But I would love to see BS 7671 move towards more digital and more readable, more machine readable. The reason for that is it's not to replace the standard. You can't replace the book. The book is always going to be needed. But I would love it to be able to be faster, to be able to use on site, for somebody to be able to ask an AI version that could be attached to it, be able to ask them real content specific questions, get real-time answers, to be able to give support when you're discussing where to code things and why you're coding things. You might know exactly, you might know instinctively that you are coding something as C2 because of a specific reason, but this would help you find the regulation faster. For me, a smarter and more consistent application of the regulations would occur if we could do this. So I would love to see that happen. I think it would make things proactively safer in our industry, and it could also help with the staying on top of things and sometimes making the regulations more accessible in our industry. So how do you go forward from this? Obviously, you've listened to us all talk today. Amendment 4 isn't just a technical update. It's about future-proofing organisations as electrification and digital infrastructure continue to grow. Having access to the right version of the standard is the foundation for compliance and consistency. So it's ensuring that everybody in your organisation has access to that. Obviously, you can access the latest standard. You can get that through BSI or the IET. I think there's going to be a link that's up shortly. But one of the most important things is to seek CPD training aligned with this Amendment 4. One of the big reasons as I said, I'm involved in the electrical industry is because it's continually evolving. A way we can stay on top of that is CPD. So it's something I'd encourage you to all be taking on a monthly basis if that's something you can be doing. I believe understanding why for the regulations is what makes it easy to apply. So the biggest thing is for anything you don't understand, ask somebody why, whether that's ringing the technical support team at the IET or Electrical Safety First, or asking the manufacturer that you're working with, why is this being applied in the way it is? Keep asking that question why. I think it's what drives our industry. That's it from me.
Thank you so much, Kirsty, and thank you to all of my panelists to provide a really comprehensive overview of what users can anticipate in Amendment 4 of BS 7671. So now we will turn to our open panel. We are receiving quite a few questions through the chat, which is wonderful. Please keep them coming as the questions keep coming through. We'll make sure that we answer as many as we can with the remaining time. So I might come to you first, Mark. We are getting a lot of questions on the electrical installation condition reports. One particular question is, how many FI on an electrical installation condition report does it need to become unsatisfactory? And how can if you do not know or find a circuit that can have an FI, be satisfactory? How can you guarantee that the installation is safe if it is not known? What if live ends in a location like a garage or loft? Bit of a technical question.
Yeah,
so.
and I get the point. There's a number of questions on this, but you could certainly conversely, you could say, you know, how can I assume it isn't safe? Why assume it's unsafe? I get your point going down the route of err on the side of caution. But what the committee discussed was, what is happening out there is, I'll word this carefully, some contractors are using the FI to get more work. And the committee debated this at length, and that's where they've arrived at. And the principal position is that what should be recorded on the ICR are things that really matter, things that are issues of safety. If you don't know something's an issue of safety, you'll flag it up. It needs further investigation. You'll flag it with the client, because you can't obviously start and pull things apart and get involved with an area without the client's approval. And your time, the client's got to pay you for it. Ultimately, you put the onus back on them. I found this. I really can't speculate what's going on behind here, because I can't find where this cable is going. For me, it's an FI, so therefore it's now down to you. I've done my bit. It's your installation. You have to provide a safe, by law, you provide a safe installation for use by your staff. You know, if it's a commercial site, whatever, you have to provide a safe installation. You have to be on top of maintenance to make sure everything's safe for them. The onus is then on the owner of the installation. So that's how I would answer that. And I think there's similar questions too on the FI. I think one of the questions was, how many FIs does it take? If you had, it doesn't mean it's instantly unsatisfactory, and that's the position that the committee has taken, and that an FI has been used by unscrupulous persons to drive more work. Well, if you haven't found something that's unsatisfactory, you can't record it as unsatisfactory, and that's the position taken. So I hope that helps. It's a good question. Thank you.
Wonderful. That's really, really helpful. Thank you very much. Luke, I might come to you. We do have a question on Regulation 551.7.2. Could you provide any further information on the integration of battery systems, particularly regarding that regulation 551.7.2, and particularly anything around the connection of generation into existing bus bar assemblies?
Yeah, well, these systems it's quite clear in the regulation that or maybe it's not clear enough as the questions come out, but yeah, the same rules apply to battery storage systems as they would for any other generation systems. That all the points of consideration on there for ideally being on a dedicated circuit, and all the protections and coordinations are still in place for this. And it's important to consider that at different points in time, that battery storage system will be a load or a supply feeding into that.
Fantastic. That's fantastic to hear. Getting lots of questions, so this is fantastic. Kirsty, I might come to you. There's a few questions on EVs. What are the main effects of the amendment on EVs and EV charging?
As Mark said, there's not a massive amount changed in the EV section. They've just got the additional indent really that allows us to use the RDC-PD. You know, we love our acronyms, don't we?
Yeah.
In the electrical industry, we like to shorten everything. So that's your residual direct current protection device. So you've got that as an additional ability to be able to use that in 722.513.3.101, and I have got that written down because it is a mouthful of a regulation. But while we're on the subject of EV chargers, something I come across in the industry quite a lot is ensuring that the regulations followed that came from Amendment 2, that RRCDs disconnect all live conductors. It's something we see missed quite a lot. I don't know if you find that as well on the IET. And obviously now with our new section on battery storage, we're now going to see more integrations between our EV and our battery storage sections.
Fantastic. Luke, I might come back to you. We're getting a very specific question on the battery chapter around the PAS 63100.
Okay.
What is the wording around PAS 63100 in the battery chapter, and how does this affect how the standard should be used? Luke mentioned that the chapter says shall take into account PAS 63100. Does that mean that the PAS is a normative reference, or is it a recommendation? I know that the PAS itself has a series of shall provisions and should provisions.
I think the fact that it is now, and I believe this is the first time that PAS has been referenced in BS 671, I think my interpretation is that installers need to demonstrate that they have considered all the recommendations within PAS 63100. So whilst PAS 63100 does have some strict terminology such as shalls, it is also Like I mentioned at the start, it tries to prescribe that they should always be installed outdoors, but then gives you options for considering where to put them indoors. So it gives strength to the argument to follow PAS 63100. The installer will need to demonstrate that they have considered all those aspects when designing and installing the product. That's probably as much as I can give on that.
That's very helpful.
Could I just
Thank
add
you very
that,
much.
remember that the PAS is for dwellings, and that chapter 57 is widened not just for dwellings, for commercial aspects too. So it's a PAS is an aspect, refer to the PAS, particularly the location of batteries.
I think that particular regulation as well, I can't remember the one that was in the slide, did caveat that point that the 63100 is only for dwellings, and for any other buildings it needs to take into account their that's right.
Fine.
So Mark, I might come to you. We've got a question on why is R1 and RN not required for all circuits, and could there be a column for recording this result?
Yes, so you're talking about the model forms in BS 7671 Appendix 6. They are available for download from the IT's website as required by, well, way back in 2005. It was obviously the Deputy Prime Minister that required that through the EAS. Anyway, that's another story. So the forms are available now as of today on the IT's website. Anyway, yes, there is a column missing for this particular test, but they're model forms. If you want to include them, then by all means include it, make your own form. So that's how I'd answer that one.
Fantastic. That's very, very helpful. In terms of Kirsty, if I could come to you, if you had one piece of advice for a practitioner picking up Amendment 4, what would it be?
Understand the why.
Yeah.
That's my thing. It's do the CPD training, actually don't just go and think, look at the list of changes and just try and work with the list of changes, because you'll never be able to apply them safely and confidently in the industry if you don't understand the why. So whether that is picking up the phone to your certification provider or to the IET helpline or to anybody that you feel could give you guidance on a specific question you have, never be afraid to ask questions. I think we're in the industry where constant learning is, I think that's the most important part of our industry, is the constantly learning, never being afraid to ask the why.
That's a very helpful piece of advice as well, and understanding the implications of what those changes actually create. Luke, I might come back to you. We're getting a lot of questions on the battery, so your chapter went down well. Are the battery regulations aimed at covering large scale up type batteries, or is it just aimed at solar installations?
It's not just aimed at solar installation. I mean, it's applicable to domestic and commercial battery storage systems, but that wouldn't. These would be unlikely to apply to industrial grid scale support specifically. So yeah, it's wider than just providing additional capacity for solar PV.
Could I just jump back into that one? I think the upside, I think it was referring to UPS, uninterruptible power supplies. Now, battery, you correct me if I'm wrong here, Luke, but battery storage, the concept is that it will go in parallel with your installation, that you can supply your installation, which is in by parallel. It's through the inverter coming out of the battery, it'll synchronize with the supply, and you can obviously run your dwelling or whatever from the battery. But the UPS isn't the same kind of technology. UPS will be provided of supply into it, and if the supply fails, the output is still there, supplying a piece of equipment. So it's not in parallel with the supply. So it's different.
Sorry,
concept. Yeah, the UPS, just the UPS. Yeah.
So perhaps a clarification question just for the both of you as well. So can you install a battery externally on a dwelling that does not meet the 1 meter clearance, but install into an enclosure that is now on the market with distributors? Very specific technical question.
I'm going to look at Luke.
That is very specific.
Very specific.
Obviously, the PAS 63100 were for consideration. So if you're demonstrating that this enclosure is going to give you additional protections that could give you solid rationale for placing it within that 1 meter, then yeah, I think you can demonstrate that you have applied engineering judgment and given us a sensible reason for installing it there. But I would definitely check the manufacturer's advice and yeah, provisions.
I would align, sorry,
You carry on.
I would align this to what's gone in for cables in protected escape routes, because well, in the previous iteration of BS 7671, the requirement was you shall not run cables that shouldn't be in that area through protected escape routes. But if you protect the cables, box it in with a fire retardant or whatever the proper expression is, it's therefore outside the protected escape route. So it's the same concept. You provided an additional piece of equipment to make it as safe as it would be if it wasn't there, or if it was 1 metre away.
Yeah,
I'd apply the same logic.
That's good. And I think the fact that when in the aspect of 63100 where it's saying about bedrooms, and then specifically saying even within a container you can't put it in a bedroom, that's doubled itself on that one. So externally, yes, internally, no.
There's a lot of detail there.
That's it. I think I'd just add to that something more generally. When you are not, I wouldn't say deviating, obviously that's a very specific word, but when you're stepping away from the specifics of a regulation, just make sure you have your engineering judgment correctly applied, and you make sure you have your manufacturer's documentation very clearly explaining your engineering judgment, why you've made that decision, and make sure all that information is recorded and kept together. It's really, really important.
Absolutely. And maybe I'll come back to you, Kirsty, as well on that point. How will feed-in from EV chargers affect consumer units and the potential overloading of bus bars? Do you have any sense on that?
Chargers affecting bus bars.
It's referring to V2G.
Yeah.
Right.
Right. Okay. So this is going back to, as Mark said before about our Amendment 3 and our bidirectional devices. If we're then looking at our vehicles then being able to go back to the grid, we've got to make sure that our consumer unit is correctly loaded for whatever's going to be coming through it. So it's exactly the same rationale as we were looking at with PV installations previously, considering our PV as a generator set. If your electric vehicle is going to be charging back to the grid, again, it is a generating set. So we've got to consider that as an additional load. So one, making sure that it's on a device that is going in the correct direction, if it's going into our consumer unit, or making sure that the consumer unit, if it is going into the consumer unit, is rated for that supply, whatever the supply the car is generating, on top of the generation coming in from the main supply. Obviously, there are ways to get around that by installing your EV charger in a separate unit rather than going into the consumer unit, which is generally, I think, the preferred method of doing it.
There's a question that Luke dealt with before, I think it was on 55172, and these are the indents showing how you shall not overload the consumer unit. And if you're preferring to very, I think it's indent G from memory, don't have it in front of me, but it's where you've got another source. So as you said, it's another source coming in, and there's a chance of overloading the bus bars. Well, therefore the designer is designing for that. Therefore the bus bars have got to be able to cope with what's going in on either side in either direction.
It's selection and direction
Yeah.
equipment, isn't it? It's correct.
Fundamentally, it's been there forever.
Yes.
But these are new concepts coming in, so therefore it's flagging up to the designer.
Thinking about it in a different way, isn't it? How long have we installed solar panels, for example, and not thought about it as a generating set? Realistically, when it goes into the consumer unit, we've just got to consider these now as technologies evolve and we start to use them and apply them in our electrical installation. That's, again, it ties back to the understanding the whys and the fundamentals of why these regulations keep moving on.
So we've got another question. Luke, I might start the first question with you and then come to you. Luke, I actually might start with you and then I'll come to you, Mark, on this one. It's a bit of a long one. The first bit to the question is around existing installations. If the regulations are not retrospective, will there be coding recommendations for duty holders arising from the new edition?
No, they're not retrospective, so it shouldn't.
Great, easy, quick answer. And then if I can come to you, Mark, what is the best method then for communicating best practice compliance given increasing technical complexity, differing engineer strengths and knowledge gaps, and risk of technical blind spots.
Oh, to Kirsty's point, isn't it about CPD is one aspect of the latter part of this question. But ESF, Luke, you've got the best practice guides. You've got we all contribute to the guidance on the coding. So no doubt this will feed into the work that you're doing over there.
Yeah, exactly. As Mark mentioned, we've some freely accessible resources on our website. So best practice guides, guides for landlords, and various other. And it's not electrical safety first guides. This is all created by industry, so it's everyone coming together to make sure that we have that aligned approach on how to do these things. So yeah, all these things will be readily updated going forward.
We have received a few questions related to protected escape routes, so I'll keep that open to the panel. We've received one question around the requirements relating to these protected escape routes. They're introduced in earlier amendments in BS 7671 and are understood that these have been developed further since. Could clarification be provided as to whether the terminology around protected escape routes as defined within BS 7671 is fully aligned with definitions and intent set out in other standards in the portfolio?
Well, that's always the intention. I'll give an example. The HRRB has been, this is high-rise, high-risk residential buildings. You see, it was high-rise and that's the problem, is that you get terminology changing elsewhere. We try to align with it, but it's like all standards that you are leapfrogging and you're trying to keep up. It's always the intention to align with others. Because of timelines, it doesn't always land correctly. But the good thing is that as organisations were able to put information out through technical guidance through magazines, even webinars like this about putting information over. So it is things change so quickly outside of a set standard. So it is about, CPD is again, it's about getting the information out when it comes along and working. But what would be the answer? We have a quick amendment to address these things, and that isn't going to please everybody. So we all work together, and I think the intention there is always to be aligned with what we can be aligned with when things change. We have a period of time to adopt requirements in national standards, BS 7671, etc. with SELEC documents, IC documents. And where something happens elsewhere, might be legislation, because legislation always trumps everything, of course. But yes, the intention is always to align, and I'll finish there.
I think just linking into that as well is everyone's working collaboratively to make sure that installations are safe and that people are kept safe. So yeah, I think sometimes there's a misconception, but there's never one. I mean, no one is setting out there to intentionally create a dangerous situation. We're all there to help members, public, and our various affiliates.
So the wording might be slightly different between standards or between different documents, but everybody's working in the same direction. Everyone's working for the same thing.
But with all British standards, we shouldn't be duplicating and we shouldn't be contradicting. So where there is a contradiction, we obviously have to act quickly. That's within the standardization process.
Yeah, absolutely, and you're completely correct. And one thing about BS 7671 is it is so heavily contextualized in the existing European harmonized international standards, and also the existing frameworks and guidance and technical standards that are available from other standards development organizations. Luke provided an example of just a few that are considered when BS 7671 is being iterated upon. So that's very helpful indeed. And maybe this is because of your reference of amendments early on. So obviously we don't have a crystal ball, so not being held to any of this, but do you foresee a future amendment to regulation 421.1.7?
AFDDs.
Yes, there we go. You know it off the top of your head. Proper standards champion, to be required to all premises.
To all premises. What I would say is we had some years ago we had a steer from the representative from the HSE, the Health and Safety Executive on JPL 64, and his position was always, if you have the technology, then why wouldn't you implement it to make us a safer world? Conversely, putting equipment like this everywhere would be overkill. So there's got to be a balance with it all. international standards evolve all the time. Of course, we've talked about that, but it's important that we engage with them and make sure that we put with our British hat, we take that information into the discussion process and put comments in of that ilk, that this isn't suitable in all places, and approach it like that. There are facilities, aren't there, through BSI to put your comments in through the standards review portal. And it's important that when something is coming along, that everybody gets on board and puts their point of view forward and makes, not just says this isn't suitable here or whatever, but put a proposal in instead of this wording like this.
Yep, absolutely.
That's something I'd like to pick up on, actually. I think it's a really important part of the process of building the standard is the comments on it. So as soon as we are working on a standard, we're getting anything ready for release. I mean, with latest, obviously, we did it with Amendment 4. We do the DPC, so it goes out for public comment. It's so important that we get them comments back. And as Mark said, it isn't just oh, well, this won't work in X, Y, and Z. It's explaining the why is always, as I say, go back to the why. It's really important, and what you'd suggest. And reference that back to other standards and why you feel that's important. We go through every single comment that comes back to JPAL, and I know BSI do exactly the same thing with all their other committees. Any comments that you put in are reviewed, so it's such an important part of the standards process. I know, especially in the electrical industry, we get a lot of complaints about new standards, new amendments. Oh, I don't like this regulation, I don't like that regulation, it doesn't apply here. The commenting process is how you get heard, and it is really, really important, a part of the whole process.
It's democratic.
I'll just add another aspect as well. There's a cost benefit thing that needs to be considered as well when standards are being developed, because if you start to mandate that you have to have X particular device in all dwellings, and it's so prohibitive in cost that people then start to go underground for people that they're going to use to do their work, so they don't have to upgrade. You start then creating more unsafe dwellings by people using non-registered persons to do this sort of work.
Or they just don't update them.
Yeah, or they're just left.
Which, it's horrible part of our industry. No, I completely agree.
So there's important considerations there, I think.
You want to maintain the usability and feasibility of the standard specifications the whole way. That is a great point. And maybe I'll stick with you, Luke. We do have a question on how have the changes required to meet the Future Home Standard been addressed by 7671?
I think particularly with the new chapter that I spoke about earlier on, that really helps to encourage adoption of the energy flexibility, so people buying into the time of use systems, encouraging the use of localized generation so people can maximize what's being generated. So I think it goes hand in hand with some of the Future Homes requirements. So yeah, complementary to it.
And perhaps this is a bit of a question for the panel in entirety. Mark, you might have a particular opinion on this.
You said only 3 questions. I was going to
Well, now you've got a million. Now you've got a million. You know what? While we've got you, we might as well. Why not have a similar rating as a building's energy certificate for the electrical safety of buildings, utilising like age of installation, EICR findings, energy saving devices, things like that? Or at least a provision, i.e. newest would receive an A for having everything in place to an F for a complete failure.
Interesting. Going back to when energy efficiency was going to be brought in into Part 8 of BS 7671, ultimately went in as Appendix 17. Within that initial proposal, there was a way of defining electrical installation. So the concept was you'd have intake in the center of the building rather than one end, so that your supplies to equipment would go out from a central point rather than the whole length of the building. And in doing so, you've followed a method, and I'm going to use the word factors, probably isn't the right word, but you could arrive at a situation where you could describe an electrical installation by how efficient it was in terms of a value. So that's it doesn't answer the question. In that methodology, there was part of it was, for instance, have a larger cable a larger cross-sectional area of a cable, so that, because when we design to the nub, you know, we keep the cable size down because we save on copper, we save on the price of the cable.
Especially now.
Yeah. But in doing so, when you keep the size of the cable down, the cable will get warm, and all the warmth that's created is loss. It's inefficient. So by going up a step in cable size, the cable doesn't get as hot. You might pay more initially for that particular cable because it's a bigger size, bigger cross-sectional area. But the running cost over the 20 years life cycle of a building, you could demonstrate that you save money, assuming obviously the cost of electricity, etc. But you could save money by having a bigger cable, less losses on a system. So there certainly is, or are, methods to define and describe an electrical installation in that method, in that style. Whether it becomes part of what we saw when, you know, was it the home sellers pack, and it was about the energy efficient rating of the building and the insulation, which obviously didn't get very far, but it could be. There needs to be a driver for it, really, doesn't there? It's a very good question, though. Thank you for that.
I think to look at it a different way, something that would probably be more applicable and more benefit to users, buyers, tenants, and landlords would be the development of the building passport, a digital repository where you can then have your electrical installation certificates, your EICRs, any updates, any installed generation and assets, and then that will build up that picture and that profile for what has been done, what is the state, what has been checked, and that will be useful for so many bodies, not just the tenants, landlords, homeowners and prospective buyers, but also building control and DNOs and everyone else that needs access to where required.
Yeah, there's something similar, I think, in the more industrial side of things. Facilities managers use, I know there's a few different systems they can use, but it's something quite similar where it produces somewhere they've got all the schematics, they've got any documentation they need. But no, I completely agree. I think especially somewhere where you can access past EICRs for an installation, for example, would be absolutely fantastic.
It tells a bigger story, doesn't it, when you've got that visibility of what's occurred.
That's it, for an electrician to get to site and be able to know more of the story rather than just a picture of what he's seeing right now.
People lose the paperwork. Owners change. Things don't get issued.
Don't get issued.
You've got to be realistic, right? So that's helpful to be aware of. I know I told you all 3 questions each, but there's a few more, and then I'll release you to your days. We've got another technical question around the comprehension of the standard that I think is worth asking. Is there any update on regulated 800 volts DC installation, and would it be covered by BS 7671 or is there another specific standard it's covered by?
Yeah, so BS 7671 covers DC up to 1500 volts. Granted, there's very little in there. Internationally, I'm involved with a number of projects. One was and this information is in the public domain, you'll find it in the IC website. But one of my projects is to revise Chapter 41, Protection Against Electric Shock, to bring in disconnection times for DC at the higher voltages. And to some extent, the information isn't there. And at the moment, it's kind of felt, well, at the real top end, it's pretty iffy, but that work is ongoing. It's nowhere near. It's relying on the work of others too, because certain groups work on electricity across the body, and they'll create the graphs and the curves that we then work to, and we extrapolate information to arrive at disconnection times. The discussions now are working on coulombs. This is charge rather than current, because what's happening is we talk about electric shock across the heart can stop the heart, but if you get your elbow, Kirsty, I'll get my elbow against Kirsty's DC buzz bar, and I might get a passage through the arm. It doesn't go anywhere near my heart or across the chest, but it goes in the top, comes out the bottom. Now that won't immediately kill me, but it could alter the blood and boil the blood, and you end up with clots, which can ultimately kill you. So this is where they're going with charge. It isn't. So with DC, it isn't just there isn't to an extent a direct comparison. I think that's a better way of summing it up. But it will come, because certainly in places like China, it's there. The technology is there. I think hot topic at the moment is plug-in PV systems. Now, we don't have a standard for it. We don't have an international standard for it. I think some of the devices coming out of China, which are working very, very well over there, haven't an international standard yet. So it is coming. We'll get there, but it's just not yet. So nothing like that has gone into 7671 in relation to DC, but it generally covers DC installations.
It's another example, isn't it, of the technology moving faster than the standards can, because we need all that information, all that documentation before we can make recommendations to go into the standard.
Yeah, that level of technical rigor doesn't happen as instantaneously as innovation does. And Kirsty, there is a question around surge protection, which I think you are the resident expert on. We do have a question related to, can SPD be installed in any orientation, or do they need to be installed vertically?
This is going to sound like the massive cop-out, but you need to speak to the manufacturer. I can't speak for other manufacturers. As a technical expert and somebody who understands the product standards, yes, that shouldn't be a problem. You could install it upside down or backwards. It should make absolutely no difference. It's not a load carrying device. We're not worrying about thermal effects or heat dissipation with it. And obviously electricity doesn't follow gravity, so we shouldn't be too worried about it. But I will say that always speak to the manufacturer you're working with. As with any individual technical devices, when you're working with a specific product, it's always best practice to seek individual manufacturer guidance when you have specific questions like that.
Absolutely. I think that's a really nice place. I know I've exhausted my panelists to wrap up the panel, but thank you very much for all of your questions, and we will endeavour to get back to you all after today's webinar. I do want to just give one question to all of you, so perhaps I'll start with Kirsty and Luke and Mark. How do you see this latest amendment changing the day-to-day reality for electricians, and is there a particular area that you think will be the most substantive change?
I think as a whole, BS 7671 is being more and more aligned with the sustainability part of the government projects, and you can see that in the things we've discussed today. Obviously, a large part of it is that battery storage. So where we're going to be seeing the industry going is more towards that. It's not taking away from the fundamental aspects of BS 7671 and our everyday electrical installations that we're making safer by the standards we have and the regulations we have in there. But we are definitely moving towards that more prosumer and safe environment.
For me, yeah, I've obviously covered off the battery storage. That's going to be a new thing to encourage users to install them safely. Power over Ethernet is a really exciting place. We're not there yet domestically, but yeah, that holds such a lot of potential. Most of the devices around us, even your TVs and everything else, can run on very little direct DC power, so that could be a very exciting place. And yeah, I think some other changes could link into what Mark was saying earlier about balcony PV systems. So I'm anticipating some interesting conversations over the coming weeks and months.
And Mark, lucky last.
Yeah, lucky last. They've answered everything for me.
Yeah.
But I echo all of that, and I think it is technology that's the driver, but it's where you've got, and again, I'm linking into what you said about CPD, Kirsty, in that going into a building, if you're not up to speed with what's going on, there's battery, there's solar, there's all this going on, different sources, and then you've got power over Ethernet, and these systems are all intertwined. And it is knowledge of those, because the law requires competency. Don't work in a system if you're not competent to do so. So I think that's what I'm getting from this. It isn't, we're at this point and it's still going to grow, isn't it? We have to keep on top of things.
Can I add one last thing?
Absolutely.
I think there's probably two schools of thought. There's lots of additional complications with the new things coming through, but there's also a huge amount of excitement as well, especially for the next generation. This is stuff to really get into and be able to hone your field on. So yeah, I think it should be a really exciting time for the industry as a whole.
I agree, and I just want to reinforce that these amendments, just to Mark's point as well, these iterations really facilitate that next step of exciting new technologies that we want to make sure that BS 7671 are introducing safely. So this is a very exciting amendment, albeit there may be some areas to get to terms with, but always a helpful thing to see a key document like this evolve with the industry. So on that note, I think it's a really fitting place to draw our Q&A to a close, and thank you again for the quality of the questions. I think how rigorous and plentiful they have been is a real testament to how much this industry cares about the work of JPEL 64, but also the technical content in BS 7671. So thank you to everyone that provided your questions, both live and in advance, and we'll endeavour to get back to as many as we can. Before I close, I think it would be remiss not to say a big thank you to our panellists today, Mark, Luke and Kirsty, not only for your ongoing contributions to the maintenance of BS 7671. It is not a small document, it is not a simple document. Without experts like you, the technical rigour of that document would be nowhere close to where it is, so thank you very much. And also for your contributions today to reach out to users and clarify some of their questions as we go through this transition of introducing a new amendment to industry. Some key takeaways for me: Amendment 4 is clearly not optional reading. It is very much a live document, and its ability to continue to adapt with industry is essential to provide that roadmap to introduce new technologies, but also make more mature technologies more robust from a safety perspective. The pace is definitely not slowing down. I don't know how many more amendments we're going to have, but it's good to know that JPEL 64 are definitely thinking about making sure that new and established technologies have that clear safety technical framework to guide practitioners. And finally, expertise matters. You've seen the experts I'm joined with by today. We also have many more in JPEL 64 and broader industry that contribute to the ongoing iterations of this standard. It is only as good as the technical debate that we have in this committee, so I very much implore you to continue to engage with the standards development process in any way in which you can. If you do not already have a copy of the Orange Book, now is the time. If you have already ordered it, it will be dispatched momentarily, hopefully as I speak. But for those who have not, you can order a copy either through the link or the QR code on the screen. It will be available or is available on BSI's Knowledge, but also at the IET's bookshop. So on behalf of BSI, thank you so much for your time and the quality of your questions today. Take care, everyone, and I hope to see you at the next webinar for the hopefully next amendment of BS 7671. Thank you very much.